the next common example of basics of probability that we're going to look at is drawing from a standard deck of cards. So if you've never played cards or seen a deck of cards, and a standard deck means there's no joker, so if you had, that's what a standard deck means. And so there's always, in this class, we always use a standard deck, so there will always be a total of 52 cards. All right, if you the set's been listed here, and you don't have to have it memorized, because again, I know not everybody plays cards, and so it's actually given to you in the formula sheet. Now, what you do have to make sure you're careful on the formula sheet is that it doesn't highlight the individual cards, so you have to remember that the hearts and diamonds are the red part of the deck, or consider the red cards. So half of the deck is red and half of the deck is black. And so the ones with the spades and the clubs there, those are listed black. And so those are the black half of the deck. So half of the deck is black, half of the deck is white. So just be aware of that when you're using the formula sheet, where it's kind of listed as white. Those are the red cards. Where they're listed as black, those are the black cards. But they're given to you, so it's there. There's your standard deck. So half of the cards are black, half of the cards are red, and so what it is in the standard deck, you've got 4 what are called suits. All right, there are clubs, which are the first ones. So these are the suits, and there are 4 of them. Clubs, spades, and those are the black cards. Hearts, and diamonds. Alright, and the hearts and the diamonds are the red cards. So half of the deck, I guess I should write, 26 cards are red, and 26 cards are black. And then each suit, there are 12. There are 13. There are 13. There's 1/4 of it. 13 clubs, 13 spades, 13 hearts, and 13 diamonds. Alright, the ace is the one with the A. So when we get to the first one, this is all of these are the ace. And when we say face cards, those are the ones with the people on them. So over here you'll see these ones at the end. There are 3 in each suit. They're called the jacks, the queens, and the kings. Alright, so the J is the jacks, the Q is the queens, the K is, and those are the ones we call them face cards because they have faces on them. Alright, so they're the face cards. Ace is not considered a face card. It doesn't have a face on it. So again, just those 12 cards, if you count them, there are 3 in each suit, so there are 12 altogether. And so that's sort of the breakdown of if you've never seen a deck of cards before, and again, everybody has different background experience, not everybody plays cards, and if you are, then you can kind of skip this part. Alright, so then you're familiar with cards. Alright, so a deck of cards. There's sort of the rundown. Now we're going to do probability. So we're going to draw 1 card. Alright, so this is just looking at 1 card from a standard deck. So the deck is put together, shuffled up, so every card is displaced and unknown where they'll land, and so that makes them all of the cards will be equally likely of being selected. That means what we mean by random draw. It means they're shuffled and it's a random draw. Alright, so probability of drawing an ace. Well, probability that you get an ace is the number of favorable outcomes out of the total, where there are 56 total outcomes, right? There are 56 cards in a deck. The probability of getting an ace, well, there are 4 aces. You can get 1 from each suit. So there's a 4 out of 52 chance. If you write that as the reduced fraction, it reduces down to 1/3. If you write it as the decimal, that's 0.077, or as the percent, so 7% chance. So 4 out of 52, which reduces to 1 out of 13 chance. And that should make sense. There's 1 in each suit, and there's 4 suits of 13. Which, again, if we write it as a decimal, 0.07, as a percent, 7.7%. Alright, probability of drawing a diamond. So the diamonds are one of our suits, right? It's the very last one listed. And if you count them, there are 13. There are always 13 in any of our suits. In this case, we're picking a diamond. And so probability it's a diamond. Well, there are 13 chances of getting a diamond out of our 52. 13 of the 52 cards are diamonds. Each suit represents 1/4 of the deck. So it should make sense that 13 out of 52 reduces to 1/4. A fourth of the deck are diamonds, so you have a 0.25 as a decimal, or a 25% chance of drawing a diamond. It would be true if I picked any suit. You'd have a 25% chance of picking a heart, club, or spade. Again, 25% of picking any of the individual suits. Probability of drawing a queen of hearts. Now, this one's very specific. It needs to be a queen and a heart. So, probability, it's the queen of hearts. Well, there is only one. If you go look at the deck, there is only one queen of hearts. That's it. So, you only have one shot. If you're looking for the queen of hearts to finish your hand or whatever it is you're looking for, you've got one shot out of 52 if you're drawing from the entire deck. There is only one of those. 1 out of 52, which is 0.0192, or a little bit less than 2% chance of getting... And again, that would be true if I picked any card. Right? If I picked the 3 of spades, 1 out of 52. So a little less than a 2% chance of getting any specific card. Alright, probability of drawing a face card. Remember, the face cards are the jacks. There are 4 of them. The queens. There are 4 of them. And the kings. There are 4 of them. They're the ones with the, if you see the over here where I've got it listed out, they're the ones with faces on it. Now again, on your formula sheet they don't have faces, but you just have to remember, I didn't mean to highlight it, that it's the J, the Q, and the K, right? The jacks, queens, kings are your face cards. Alright, so drawing a face card, there are only 12 of those. So 12 out of 52, which again, write it as either the reduced fraction or the decimal. Again, whatever they ask you for. So 12 out of 52 would be 3 out of 13, and that should make sense. Each suit, which there's 13 of them, there are 3 shots that you get a face card, which is the decimal 0.2307, so I'm just going to leave it 2-3, so there's a 23% chance of getting a face card. Any of the face cards, right, from any of the suits. Alright, so that's a deck of cards example. I'll stop there and I'll pick up the next example in the next video.